my name is Steve Young. I'm a product specialist at Astronics Test Systems. Welcome to another short video. The question today is, how easy is it to add a new device to the library? The simple answer is very simple. So today we're going to look at adding a DG418 to the library. The DG417 already exists within our library. You can see, compare both devices here, that pin for pin they're exactly the same. The only difference being that the logic is reversed. So a logic 0 on the 417 turns the switch on, and on the 418 it turns it off. So all we're going to do is modify the existing device and then compile it and add it to our library. So all we do, we open our TestVue. TestVue is our platform that's common across all of our test systems. So you can program one, you can program them all. And we simply open our Libraries tab. And in our Libraries tab, I already have the DG417 open. And for those new to TestVue, everything in green is a comment. So this little piece of boilerplate at the top is just a comment for reference. It tells you who programmed it, when they programmed it, what spec they used, and you'll update this if you need to change the device in the future. So everything in red is a keyword. All of our keywords are there to perform a particular function. So this section here, that sets all of our TTL levels and all of our input and output voltages. The next section, the def pin section, is simply replicating the pin information on your data sheet in a way that the TestVue understands it. Okay, and here's our functional pattern down here. The 417, an input low, turns the device on, and we know from our data sheet that an input low on the 418 turns the device off. So we just need to reverse this pattern to make it perform. So what do? We go in, we simply edit the 418, and we simply modify our boilerplate here. It's the same spec that we're using. So now we have a 418 and a 418, and we simply modify the input pin now goes high, and then turn the switch off, we take it low, and then to turn this switch back again, we take it high, and we just replicate that behavior again, just to test it back the other way to make sure the device works both ways. And there we go. So that's the code modified. The code is simply replicating the truth table in the spec. Okay, so we can shut down our spec now. So once our code has been modified, our part number has been updated, we perform a compile. So we simply perform a compile, and first of all we do a syntax check. We check syntax, and as you can see over here that our syntax has passed. If there's any errors, you'll need to spend a few moments correcting those. And then we go back, we compile, we remove the syntax, and we now need to add it to our device library. And we click OK. So now we have our new DG418 in our functional library, and we now need to add a DG418 to our device library. It's the device library that gets searched when you're adding components to your PCB. So you need both. You need a device library item and a functional library item. And then we click OK. Here's our new device. We now have a DG418. It's in our new devices library. This is our TTL levels for inputs and outputs. And we click OK. Now, we can add a data sheet for this device. the DG417 already exists, so we can copy that data sheet and include that in our library. So here we can say DG41, and there's the 417. We can click the 417. The library covers 3 components, so we can click OK. The data sheet has been added to DG418. So do we want to add a symbol? At this point we say no, because what we're going to do is open up the symbol for the 417, and we simply add save as, and we change the 417 to a 418. Keep that in the new devices library, and we'll overwrite that. So that's how easy it is to add a new device to the library. So thank you for watching, and see you on the next video.